All right, so we've reached the generative AI intro by Lewis. So Lewis, I'm going to pass it over to you.
Hello, can you hear me and see me?
Yes, we can hear you and we can see you.
Great, so I'm going to share my screen. So do you see the presentation here? The actual presentation?
Yes, we can.
All right, perfect. So yeah, let me know if the slides don't move or something. So yeah, thank you very much for such a wonderful introduction for such a wonderful event. My name is Luis Serrano and I work at Cohere. I'm the lead of developer relations team. And today I'm going to tell you a very quick and fun and non-technical introduction about generative AI that will be followed by a video by Ed where he explains it more in detail. So this is my favorite example of generative AI. It's this one. I don't know if you've seen this page. It's called whichfaceisreal.com. And it puts a real face of a person and a face that is generated by a computer. So who wants to take a guess of which one of these two is the real person? And I don't know if we can get people in the chat to say something, or if you guys among the stage want to take guesses. I see people in the YouTube saying left. Very well, very good. Yep, everybody caught it that it's the one on the left. Mostly because I see another person right beside, and those are hard to find to make. The face is easy to make, but the background is hard. As you can see, the background on the right is kind of strange. Let's do one more. Which one of these two, left or right? See that this group is pretty good. It's got like an 90% accuracy. Let's see. What do you think of this one, left or right? So again, I see a bunch of there's some right, left. Right. So this one's more this one's harder, right? Actually I wouldn't be able to tell, but if you see on the top left, there's some letters. Those letters are impossible to create in the background with that. These are used with GANs that actually wouldn't create it. So it's actually left. So you see, so that shows how good generative AI is. And this is from a few years ago. This is not even the state of the art. So it's fascinating. There's also obviously what Cohere does wonderfully, which is things like text generation, text summarization. So here's, for example, a prompt. You give it a prompt, so it's going to generate a blog, a first paragraph of a blog. So you can say how to get started with rock climbing, and the audience is athletes and the tone is enthusiastic. So it generates something pretty enthusiastic and for athletes, right? If you're an athlete looking for something, blah, blah, blah. But I can change the prompt. So there's actually a lot of what you learned here is going to be a lot of prompt engineering, how to make the best prompts to get the best. So I'm going to say how to get started with rock climbing. Audience is mathematicians. I can make fun of them because I'm one of them. And then the tone is angry. So it wrote this, and it does sound angry. I feel the need to vent about the people who write in to ask blah 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 blah. So it is truly fascinating what these things can do in terms of text and image. But let me give you a bit of an idea of machine learning. So there's many types of machine learning, but the one you may have seen, the two big types are classification, which is a type of supervised learning, and generation, which is what we're gonna be working, and that's more unsupervised or semi-supervised learning. So what is classification? Well, it's answering yes, no questions, right? So you have, and generation is creating new data. So classification, let's say you have the model in the middle and you put in things. So you put in, for example, images, and the model is supposed to tell you if the image is a face or not. And so a good model will say yes for an image if you put in a face, and if you put a truck or noise or anything else, it will just say no. Whereas a generative model is different. This particular one, for example, has no input whatsoever, and you just press a button and it generates, if you give it data of faces to learn, it generates a face. If you press the button again, it generates a different face every time. So as you can see, it's much harder to do the one in the right than the one in the left, both for a human and for a computer. And the same thing happens with text. For a text classification can be anything that answers a yes, no question. For example, sentiment analysis. If you have a sentence I'm having a delightful day, the model will say, yeah, that sounds like a happy sentence. And if you put something sad, it'll say that's a sad sentence. And this have many applications, for example, spam detection, right? Like if you put in an email that says, oh, this sounds like spam. So numerous applications. And generation, you can also do things like now you enter a prompt. You can say, for example, tell me something about a happy day, and it'll write a story about the happy day. The sun was shining, the grass was growing, etc. Like the blog post that I showed you before as well, right? So again, much harder to do generation than classification, because it's much easier both for a human and for a computer to say yes, no to something than to create stuff out of nowhere, right? And as you can see, there's two kinds here. The first one has no input. I just press a button and a new face appears. I don't tell it anything. And the second one has an input, which is I tell it what to write about, right? So those are two types of generative machine learning. The second one is called conditional generation, and both are useful, but conditional generation is just much more hands-on useful, right? You can say, I want to write an email about this, I want to write a tweet about this, I want to make an image about this, make a logo about this. So it's just much more useful. So then that's the one we're doing today, and that's the one we do here in generation, right? So there are many other applications of AI. So here's where you can actually generate images with a prompt, right? So here's one, a photorealistic picture of a cute cat wearing a suit, typing on the computer, high quality. You can put anything and it's just gonna generate some amazing images. This image will appear, make an appearance later in Sandra's talk. You can also generate video. This is just more in the research stage, but and believe it or not, there's a video there. It was in weird format. I couldn't actually embed it, but the dog is actually flying, believe me. And you can put the input, right? A dog wearing a superhero outfit, etc., etc. Some things are more that you can actually generate code. If you go to this app dbuild.co, you can actually put in the instructions for what code you wanted to write, and it'll write an app with that code. Obviously, simple stuff only, right? But that's fascinating. And a recent research development that I found pretty fascinating, less visual but pretty fascinating, and is generating solutions to problems. So let's say you're solving an optimization problem, for example, portfolio optimization or mapping or something like that, and you've managed to find a bunch of solutions on your own. Like say you have 1,000 solutions that are pretty good. You feed them into a generative model, and then you press the button and spits out more solutions. And many of them will be garbage, but some of them will be actually pretty good solutions. So with that, some researchers have been able to actually beat the state of the art in portfolio optimization using just a blind generative model that just receives data and spits out data that looks a lot like what they receive. So it's pretty fascinating, and applications are just numerous. And just to give an idea of what models there are, GANs were the sort of state of the art, the ones that generate these images by itself. And when it comes to conditional generation, stable diffusion is really the what's really generating these amazing images from prompts. And for generating text, we use transformers, which are a very interesting architecture. It can do anything: translation, writing blog posts, summarizing articles, etc., etc. So that's pretty much all. I wish you all the best in this hackathon. I hope you have a great time. I hope you learn a lot and are able to create amazing demos that we'll enjoy later. So here's the time for Ed's video. I'm gonna stop sharing here. If you have any questions, feel free to ask them in the chat.
All right. Louis, thank you very much for that. That was absolutely wonderful and great. I always wondered to myself, like, what are the practical applications? And it's really good to see, especially like I loved your use of the face generation, because we see so much AI generated artwork nowadays. I mean, I cannot go to a event or conference and not see a PowerPoint presentation that uses some kind of AI generated images. But it was your use that had us choosing between the two faces that I think was fabulous. And every single day I have the privilege of being a little bit surprised by how AI can be applied. And this is a perfect example that you took a technology that's exists, and you've just made a really simple puzzle or game out of it. And that is exactly what we want this event to be. We want people to take what exists, put a spin on it, put their own way, hack it, prompt hack it, change it a little bit, and come out with a completely different application. We've really seen technology across time become fundamentally remixes of the knowledge that we possess. And in certain applications, they become revolutionary. And that's what we absolutely wish all of your creations